For the last few videos, we've been looking at cars through the worlds that created them. The Soviet Union built cars to survive the Soviet Union. Britain built some of the world's greatest cars and then discovered that building great cars and building a great car industry were two very different things. And India has its own answer to the problem. What happens when you have to build cars for an enormous country with enormous needs and not an enormous budget? But there's a problem. Every generation thinks it knows what the car of the future is going to look like. And we're about to find out whether our generation is any better at it. Because by 2030, the car is supposed to be electric, autonomous, connected, software defined, and possibly capable of doing half the driving while you're busy pretending to work. Some of those predictions will probably come true. Some will age spectacularly badly, and a few may already be happening without us noticing. So rather than asking what the car of 2030 will look like, let's ask a slightly more interesting question. How did we get the future so wrong in the first place? We've spent all this time looking backwards. Now let's make the uncomfortable mistake of looking forward. The funny thing about predicting the future is that the people doing it are rarely stupid. They usually have the technology, they have the engineers, they have the money. What they don't have is hindsight. In the 1950s, the future of the automobile looked nuclear. Ford even imagined the nuclear, a car powered by a miniature nuclear reactor. And honestly, when you had just split the atom, it probably seemed perfectly reasonable to assume we'd eventually put one under the bonnet. Then came the age of computers. Suddenly, the car of the future wasn't powered by the atom, it was going to drive itself. By the end of the 20th century, we had already spent decades imagining roads full of autonomous cars, flying cars, and vehicles that will make the ordinary steering wheel look like an antique. And yet, here we are, in 2026, still arguing about parking. Because predicting technology is easy, predicting which technology survives contact with reality is considerably hard. The nuclear car wasn't defeated because nuclear physics stopped working. It was defeated by things like weight, cost, safety, infrastructure, and the rather unfortunate problem of what happens when your family car needs a reactor technician. And that is the part our previous stories kept revealing. A car isn't just an engineering object. It is an engineering solution trapped inside an economic system, a culture, a road network, a fuel supply, and a particular moment in history. Which means the car of 2030 won't simply be whatever engineers can build. It will be whatever the world can actually support. But here is where things get interesting. We got the future wrong, sort of. Because if you parked a modern car next to one from 1950, the people from 1950 will probably think we'd completely lost our minds. The engine starts without a choke. The car knows where it is. It can watch the road. It can warn you when you're about to hit something. It can adjust the suspension, control the brakes, manage the engine, talk to satellites, and in some cases, drive itself. And you can sit inside it and ask a rectangle of glass where the nearest petrol station is. So perhaps the futurists weren't completely wrong. They just made one enormous mistake. They imagined the future arriving all at once. Instead, technology arrived piece by piece. The computer didn't replace the car, it disappeared into it. The electric motor didn't suddenly make the combustion engine obsolete. It quietly found its way into hybrids, auxiliaries, and eventually entire drivetrains. Autonomous driving didn't arrive with a robot taking your place behind the wheel. It started with a radar sensor, then cruise control, then lane keeping, then cameras, then increasingly sophisticated systems trying to work out whether that thing ahead of you is a pedestrian, a bicycle, or a plastic bag having a particularly ambitious afternoon. The future didn't replace the old car, it accumulated on top of it. And that's probably the most important thing to remember when we start talking about 2030. Because the car industry isn't starting from scratch, it is carrying more than a century of compromises into the future. And some of those compromises are about to become very expensive. So, what actually changes a car? Or if you like, the forces pushing the car into 2030. Usually, It's not a designer waking up one morning and deciding that everybody needs a touch screen the size of a television. It's pressure. The Soviet car had to deal with distance, climate, and infrastructure. The British industry had to deal with competition, capital, and industrial decline. India had to deal with scale, cost, and the simple reality that millions of people needed mobility that they could actually afford. And the car of 2030 is being squeezed by an entirely different collection of problems: energy, emissions, urbanization, semiconductors, battery supply chains, Chinese manufacturing, software, and perhaps the most awkward one of all, what people actually want to pay for. Because these forces don't necessarily point in the same direction. Governments want cleaner cars, customers want cheaper cars, manufacturers want higher margins, technology companies want more software inside the vehicle, enthusiasts want fewer screens and more engines, and shareholders, rather inconveniently, would like everyone to make money. So when someone tells you that the car of 2030 will be electric, autonomous, or fully connected, the more useful question isn't whether the technology exists. It does. The question is, which version of the future can survive the economics? Because that's where automotive predictions usually go to die. And right now, the biggest battle is happening underneath the bonnet. The century old argument over what should actually power the car is being reopened. So, why 2030? Why not 2040 or 2050 or some conveniently distant year where I can make predictions without having to be around when they age badly? Because 2030 is close enough to be interesting. It's only 4 years away. That means we are no longer talking about some distant science fiction future. A lot of the technology that will define the cars of 2030 already exists. The batteries exist, the autonomous systems exist, the software exists, the factories are already being built. The question is no longer whether these things are possible. It's which ones actually make it out of the laboratory, survive the accountants, reach the showroom, and eventually end up on someone's driveway. And there is another reason I chose 2030. A lot of automotive industry's biggest promises have been aimed at this decade: electrification, autonomy, software defined vehicles, new manufacturing systems, new players entering the industry, and a fundamental change in how we think about owning and using a car. So 2030 gives us something previous generations of futurists didn't have. We are close enough to see the future arriving, but far enough away for the outcome to still be uncertain, which makes it a rather dangerous year to predict. And that's exactly why I picked it. If there's one prediction about 2030 that has become almost impossible to avoid, it's this: electric cars are taking over, and they are certainly getting harder to ignore. But there is a strange habit in automotive discussions of treating the future like a courtroom where one technology has to murder the other before the credits roll. Electric versus petrol, battery versus combustion, old versus new. Except that's not really how engineering works. The engine is not dead yet. The internal combustion engine has spent more than a century being optimized, refined, and mass produced. It has an enormous industrial ecosystem behind it. Fuel stations already exist, mechanics already understand it, supply chains already exist, and most importantly, millions of people already own one. The electric motor has the opposite advantage. It is mechanically simple, it can deliver enormous torque instantly, it can recover energy under braking, and the battery can be integrated into the structure of the vehicle in ways that simply weren't possible with a fuel tank and an engine. But batteries bring their own problems: materials, weight, charging infrastructure, grid capacity, cost, and the rather inconvenient fact that electricity still has to come from somewhere. So the real question isn't, will electric cars replace petrol cars? It's, where does each technology make the most sense? Because a city car doesn't have the same requirements as a long distance truck, a family SUV doesn't have the same requirements as a sports car, and a car in London doesn't live in the same world as a car in Nairobi, Mumbai, Sao Paulo, or Shanghai. which means 2030 probably won't have one answer. It will have several, and that might be the first prediction worth making. The future of the car is probably going to be much less uniform than people predicting it. The strange part is that the technology may become more standardized while the cars themselves become more divided by where, how, and why they are used. And that brings us to the next battle. Because once you stop arguing about what powers the car, you have to ask what the car is actually for. For most of the 20th century, the answer was fairly simple. A car was a machine you bought, you put fuel in it, you maintained it, and eventually you got tired of looking at it and bought another one. The manufacturer sold you the machine, and after that, the relationship was mostly your problem. But the modern car is beginning to challenge that arrangement because increasingly the physical machine is only part of the product, the rest is software. You can now receive updates without visiting a workshop. It can change how its systems behave, it can collect data, it can connect to the internet, it can recognize its surroundings. And manufacturers are discovering something rather interesting. Software doesn't have to be sold only once. A physical car can be sitting in your driveway for 10 years. Software can keep selling things to you for 10 years. That creates an entirely different business model. Instead of asking, what options do you want when you buy the car? The industry can eventually ask, which features would you like to keep paying for? And this is where the future starts getting slightly uncomfortable. Because a mechanical car has a very obvious limit. If you didn't buy the larger engine, you don't have the larger engine. Software doesn't have quite the same courtesy. The hardware might already be sitting underneath the bonnet. The manufacturer may simply decide that you haven't paid to use all of it, which brings us to one of the strangest possibilities of the 2030 car. You might not actually buy the complete car anymore. You buy the hardware, then you subscribe to the experience, just like my channel. And suddenly, the old argument about horsepower starts looking very different. Because your car might physically have 400 horsepower, but apparently your monthly payment only includes 300. Software is becoming part of the car. There is one obvious question. How much of the driving are we actually going to do ourselves? This is probably the oldest modern prediction about the automobile. The self-driving car has been just around the corner for so long that the corner itself should probably have a road named after it. For decades, we've been shown visions of people sitting in their cars reading newspapers while the machine handles everything. And technically, we are getting close. Cars can already maintain speed, they can keep themselves centered in a lane, they can brake for obstacles, they can change lanes, they can monitor the driver. Some systems can handle substantial portions of a journey without constant human input. But there's a massive difference between assisting a driver and replacing one. A human can look at an unusual situation and think, that's weird, I should probably slow down. A computer has to work out what weird means. And roads are basically an endless supply of weird. A pedestrian standing in the road, a motorcycle filtering between lanes, a temporary road sign, a police officer waving traffic through an intersection, a pothole filled with water, a goat, and yes, somewhere in the world, probably several goats. The problem with autonomy isn't simply teaching a machine how to drive. It's teaching a machine how to deal with everything that isn't supposed to happen. And that is why I suspect the autonomous car of 2030 will be much less dramatic than the one we were promised. Not everybody asleep in the backseat. Not every road transformed into a robotic highway. Instead, autonomy will probably arrive in layers. A system that works brilliantly on a motorway, another that handles traffic jams, another that operates inside a mapped urban area, and eventually, perhaps, a machine capable of doing the whole thing. But that last step is the difficult one, because going from the car can drive to the car can drive anywhere isn't a small improvement. It's an entirely different problem. And there is another problem nobody in the glossy concept videos likes talking about. If the car can drive itself, who actually owns the responsibility when it comes? Gets something wrong. Because once the machine becomes the driver, the steering wheel stops being the most interesting thing inside the car. the legal system does. And there's another change happening quietly. The modern car doesn't just respond to the driver anymore, it learns from its environment. Cameras, radar, GPS, and increasingly powerful computers allow it to understand what's happening around it in ways an older car simply couldn't. That changes what a car can actually do. It can predict a collision, adjust its behavior, optimize energy use, learn routes, and increasingly update its capabilities after you've bought it. This is less about replacing the mechanical car than adding another layer to it. The old car was built around mechanical feedback. The new one is built around information. And by 2030, that may be just as important as what's underneath the bonnet. But all of this raises a more basic question: who is actually going to build these cars? Because the future of the automobile isn't being decided only in laboratories, it's being decided in factories. And this is where the automotive world is changing very quickly. For decades, the industry was dominated by a relatively small group of manufacturers from Europe, Japan, and America. Now, China has become one of the world's most important automotive manufacturing centers, particularly in batteries and electric vehicles. And that matters because automotive history has never been just a competition between better cars, it's been a competition between better ways of making cars. Henry Ford didn't invent the automobile, he changed how cheaply it could be produced. Japan didn't invent the small car, it became exceptionally good at producing reliable ones. And now a question is emerging: what happens when manufacturing speed, software, and battery technology become as important as the engine? Because by 2030, the companies that matter most may not be the one with the longest histories. They may be the ones that can adapt the fastest. And this is where the old automotive order gets interesting. Speed becomes an advantage. A traditional car company might spend years developing a new model, but software doesn't think in model years. Phones don't get a completely new processor every 7 years. They get better constantly. And electric cars are increasingly bringing that mentality into the automobile. Battery chemistry improves, software updates, manufacturing changes, new models arrive fast. That creates a completely different competitive advantage: speed. Not just speed on the road, speed in development, speed in manufacturing, speed in adapting to what customers want. This is one reason Chinese manufacturers have become such an important force in the EV market. They aren't simply producing electric versions of the old car, they are competing across batteries, electronics, softwares, and manufacturing at the same time. And that puts the established manufacturers in an uncomfortable position. Because a company can survive being late to a trend, it is much harder to survive when its competitors can iterate faster than it can react. And that may be one of the defining battles of the car industry by 2030. So, what will 2030 actually look like? After looking at how badly previous generations predicted the future, I'm going to make the mistake myself. Here are my bets. By 2030, electric cars will be normal, but the combustion engine won't be dead. Hybrids will probably be far more important than the simple EV versus internal combustion engine argument suggests, because different parts of the world have different infrastructure, economies, and priorities. Autonomy will improve dramatically, but it won't be universal. We'll see cars that can genuinely drive themselves in specific conditions, while the completely autonomous car that works anyway will remain much harder to achieve. Software will become one of the defining parts of the car. Not because the mechanical side disappears, but because the machine will increasingly be capable of changing, learning, and improving after it leaves the factory. Chinese manufacturers will be much harder to ignore, not simply because they make electric cars, but because they are competing on batteries, electronics, manufacturing, and development speed at the same time. And I think there's one prediction I'm reasonably confident about: the car won't become one thing. There won't be a single replacement for everything we've driven before. There will be different cars for different problems, different technologies for different roads, different compromises for different economies. And that brings us back to the cars we've been looking at throughout this series. The Soviet Union built cars for its world. Britain built cars for its world. India built cars for its world. And whatever we end up driving in 2030 will tell us something about the world that produced it. That's why I'm less interested in predicting what the car will look like. I'm more interested in seeing what kind of world makes that car make sense. And if you're watching this after 2030, well, now you know exactly how badly I did.